Okay, good morning. Welcome to
FamilyMath445.
FamilyMath445. So we're going to continue on with our tiling discussion from yesterday because I actually saw a really neat paper about tiling from Richard Stanley. I found it completely by accident when I was searching for some other tiling activities yesterday. So my first question is, do you think you can tile this chessboard with 2x1 dominoes, where each domino is either going this way, horizontally, or vertically, and covers exactly 2 squares every time, so like that. Do you think you can cover the chessboard?
So like each. So would this square be covered?
Yeah. So the chessboard's a little bit bigger than our dominoes, but right, this domino is covering those 2 squares. Do you think you can cover the chessboard?
I think so.
Yeah.
Alright.
So there might be multiple ways to do it,
Okay.
but
So
you
it's
can just
one of the simplest ways.
sort of line it up like this.
I don't know if I almost got the exact right number. Okay. So that's actually not too difficult to do, right?
No.
And there's probably
Probably a couple other ways.
quite a few ways to do it. In fact, someone actually, believe it or not, figured out how to count the number of ways to do this.
Wow. Well,
Yeah, which is pretty crazy, actually. But that's not what we're going to do today. So what we're going to do today is, well, how many dominoes did it take, by the way, to cover this?
32.
All right. What are some ways you could have figured that out?
Well, 64 squares divided and 2 squares on each thing.
Okay.
So, 32.
32. Okay, so what I'm going to do now is I'm going to take away 1 domino to leave 31 dominoes, and I'm going to take away the 2 opposite corner squares. Okay, so who are these little 3D
I
prints?
think it's Squirtle and Pikachu.
Okay, so I'm going to cover them with Squirtle and Pikachu. And I'm going to ask you, do you think you can cover this now with 31 dominoes?
Well,
So-
yes, I think so. Well, maybe if we start from here and kind of shift everything over and then use this.
So we'd have to shift this over. You sort of have to zigzag. Around,
And then you have
if this would work.
put this square. No, we have this empty square. I'll keep this here.
I'll make sure it covers 2 squares. I'll make sure that one above you.
One here. Well, we have to put it there. So we have an empty square over here. But we have to put these 2 empty squares together. We ever do that over here?
So if there's 2 empty squares that
I have to try to put them.
we can't seem to get them so that they're right next to each other so we can cover.
Huh. What do you think the problem is?
Well, you have these 2 ones on the ends, so maybe if you put them right next to each other, you could.
Yeah. I think it's the way that we took them away.
Ah, okay. What do you think it is about the way we took them away?
Well, that since they're not right next to each other, and so we took them away on a diagonal, and here they're always separated by a diagonal, or they're always far apart.
Okay, well that's sort of, let's try to get a little bit more specific with how the argument works, because, you know, the idea that they're on a diagonal might be, maybe that's right. But we don't know. We don't know what would be special about diagonals, but there might be something else that's special that we can focus on.
Well, maybe it's that we have only 7 squares on this row and 7 squares in this row.
You have 7 squares on all of those.
Yeah.
The edge.
Because you take one out.
Okay.
And then you have to kind of have these extra pieces in.
Well, except if I put them right next to each other, like you suggested, I would still have 7 squares on this row and only 6 on that row, and I would be able to do it, right?
Oh yeah.
Mm-hmm.
So let's keep thinking.
So what's the problem with this arrangement?
So well, everything is kind of shifted over here.
Well, I see that each domino can cover a black square and a white square,
Okay.
and we covered up 2 white squares.
All right.
So a domino wouldn't be able to cover up
2 black.
2 black squares.
Oh, interesting. Okay. So what did we take away?
We took away 2 white squares.
So maybe if we took away a white square and a black square. So if we shifted this.
Yeah, maybe. But let's before we go on to that, let's finish this argument. So I took away 2 white squares. What does that mean I have left?
That means you have 2 black squares left.
Okay. How many white squares do I have on the board now?
You have
So you'd have 30.
Okay. And how many black squares?
32.
Okay. So what's the problem?
That you can't have you can't pair them all up.
You can't pair them all up.
more black squares.
Interesting. There's more black squares. Each domino covers a white and a black square. And I have more black squares than white squares. So I can't cover this with dominoes.
Yep.
But you suggested let's take a look at if I take away a random white square and a random black square. What do you think?
I think
Actually, let's go to the next movie.
Okay.